To dynamically negotiate trunk, we got two protocols. One is .1q and then ISL. You remember we saw some two classes before, when you have two switches, when you have two Cisco switches like this, by default the link will be auto one side and both the side it will be auto, but when I say trunk on one side, that is when I turn on mode, when I turn on the trunk, through negotiation this can become trunk. Through negotiation you can, when you type show MAC address, show interface trunk, you can see N. Trunk is because of negotiation. In the videos I clearly show these things. You can also see that in packet tracer. So there's a program there, there's a protocol there which is responsible for negotiation of trunk between these two. For that, Cisco has got its own protocol called ISL, and there is another one industry standard called .1q. ISL and .1q. Which is more popular? It's .1q is more popular. Why .1q is more popular? The reason why it's more popular is it is neutral vendor. There is no vendor. So it is seen in every vendor switch. Even Cisco switches have got .1q. Non-Cisco switches have got .1q. So if you use .1q, your switch can negotiate or talk to any switch. But if you use ISL, your switches cannot talk to other switches. They can talk only to a Cisco switch. They cannot talk to a non-Cisco switch. So people started using .1q so there won't be any problem of negotiation of trunk. There is another very important reason why .1q is popular. .1, yeah, very smaller in bit size. Meaning .1q reasonably uses only 4 bytes of field, 4 bytes of field information for this trunk negotiation, for carrying the VLAN ID, the priority, all the stuff. It is reasonably having 4 bytes. It's a reasonable size. But this guy has got 34 bytes. Very poor. 34 bytes. It is like, someone doing a job in 4 minutes. The same job is done by someone in 34 minutes. Which one you say is good? This is good because in 4 minutes work is done. Same work the other person has taken 34 minutes. Is no good. Same output, same accuracy. So that's another reason why people like .1q. Size of the bits used. Now at least if this 34 is properly used, then you are happy. But this 34 bytes are not properly used. I'm sorry, it's not 34, I think it is 32. 26 bytes on the left, or 20, no. Yeah, it's 26 bytes on the left. I think even 32 is also wrong. 30 bytes. 26 bytes on the left and 4 bytes on the right. So 30 bytes. Anyway, it's a big number. They are nowhere related. Very big number. Where is 30 or it's above 30 above. 30 or 30. It should be 30, most probably 30. Or sometime it may be 32 also. I'll check and tell you. But this has full of junks. Meaning this 30 byte of information is not really related to any VLAN or priority or MAC address, nothing. Only few bits are being used, around 16 bits are properly used. All the remaining bits I'm not talking about bit here, 30 bit. I'm talking about byte here. 30 bytes in which around 16 bit is what properly used. That is 2 byte is what properly used. All the rest are junks, meaningless garbages that is being sent and processed by every trunk port. That's the reason ISL is not in industry today. Even Cisco, from their devices, they have removed ISL now. It's only .1Q. So .1Q is the trunking protocol that is popular. But for CCNA exam, we need to know this difference, but we have already crossed the CCNA limit. In CCNA, they ask the question, which one encapsulates, ISL or .1Q? Answer is ISL. ISL will encapsulate. .1Q will just add a shim of value. Only tagging is done in .1Q. Now what is that tagging? What is that encapsulation? Now when this switch 1, let me call this a switch 1 and this is switch 2. When switch 1 and switch 2 now send some frames, when switch 1 sends frame, see this is the frame, what ISL will do, it will add the 26 byte of information and 4 byte of information this side, totally 30 bytes. In this 26 bytes, somewhere here it will have the VLAN marking. Let's say the traffic is coming from a PC which is a member of VLAN 10. So it will say VLAN 10. And a new layer being added as an encapsulation, and this packet goes down to this trunk. Now this one, on receiving the packet, it identifies the packet is for VLAN 10 and it removes the VLAN marking, it removes the encapsulation and sends only the frame down to the computer. This is what called as encapsulation, adding an additional layer. Whereas .1Q is not like that. .1Q, see the packet is coming from VLAN 10 domain. It wants to go to this VLAN 10 PC B. A wants to go to B. They are both are in same VLAN. Now the switch, what it does is it takes the frame, and what it does is it breaks the frame, or before sending out it decapsulates, it removes the cover, layer 1 cover, and in the layer 2 it adds a shim of value, a small bit of value, in that which it has got VLAN ID, priority and so on. It adds the this information in between, and then again put back the encapsulation. So no new layer is added. The existing frame is being altered. Layer 2 is altered. Because you are altering the layer 2, only small changes need to be done to CRC. In layer 2 there is a field called CRC, cyclic redundancy check. So that will be slightly altered and then packet will be sent down. So no encapsulation happens here. Instead only tagging happens. This is what I mean by tagging, adding information to layer 2, data link layer. So on the receiving side, what this trunk port does is it decapsulates it, it removes the cover and it finds the shim with VLAN 10 ID. So it throws the shim out and takes only the normal frame and send it to VLAN 10 members. So this is how .1q is different from ISL. Which one encapsulates ISL? Which one do alteration of frame? .1q. This is more and more and more and more than enough in this topic. Going deep into this is nothing wrong, but it's for your satisfaction. For me, according to me, it's a waste of time. Seriously, if you go deep into this and you want to be a network engineer in future or administrator, it's of no use going deep more than this. Even this size also doesn't matter. ISL no more, it is being supported even in Cisco routers. Then why you want to go deep? Not necessary. There was once a protocol called ISL which was doing trunking, but now we don't have because of drawback. Whose proprietary it is? It is Cisco proprietary. ISL. .1q is industry. What does .1q means? It is actually IEEE 802.1q. It's a standard. It's a standard that is for trunking. So this one has become a pet name. .1q instead of calling the big name IEEE 802.1q standard, they started calling it as .1q standard. .1q protocol, which is a replacement for ISL. ISL stands for Inter-Switch Link. Alright. So next is the configuration part. Let us say this switch supports both ISL and .1q. If it supports both, only then you have a problem. If it supports only one, you no need to go and enable. If it supports only .1q, you no need to say enable .1q, because that is the only thing that is supported. You can simply go to this interface and say switch port mode trunk. Automatically .1q will be running because that's the only protocol there. The problem starts only when you have two protocols. If you have both ISL and .1q in your switch, when you have both ISL and .1q in your switch, only then the problem starts. You need to mention which one to use before you say this. Very important. Before you say trunk, switch port mode trunk, before you say this, you need to say whether you want to use ISL or .1q. Only then it will accept this command. Now in any switch in production, if you try giving this command, if it throws an error, then you need to be in an alert mode. You need to remember that it has got two protocol. I need to mention what to use. So if you want to use .1q, say switch port encapsulation, switch port trunk, switch port trunk encapsulation .1q. You must mention this first, followed by switch port mode trunk. When I give this command switch port mode trunk, it didn't show me an error, which means it has got only one protocol. It may be ISL or .1q. That's why it didn't show me an error. If it shows an error, it has got both the protocol. I need to enable any one of this first. If you want to have ISL, instead of .1q, you say ISL. But ISL is no more in Cisco switches, so you need not to worry. You just go and give this command alone. Switch port mode trunk, .1q gets enabled. But in very old switch, only ISL will be there. Very old one, very old. 1990, that time. And then the Middle Ages, you had both. Later age, the golden age in which we are studying this, you got only .1q. You need not even mention it. switchboard trunk encapsulation dot one queue. It is understood it will take dot one queue. So this is the configuration part. You go under the interface and give this command and give this command. Optionally, if you have VLAN 10, VLAN 20, VLAN 30, VLAN 40, VLAN 50, and you don't want to allow VLAN 20, 30, 40, you don't want to allow VLAN 20, 30, 40 to be using this trunk. I don't want to allow 20, 30, 40 to use the trunk. Who are all allowed? The allowed members are 10 and 50. Then what I can do is go under the same interface, trunk interface, and say switchboard trunk allowed VLANs 10, 50. Only 10 and 20 will be allowed. If you didn't say this, all VLAN will be allowed. All VLAN. Whatever VLAN you create, those traffic will be allowed to pass through the trunk. So this is what the story about DTP. I'll be doing and showing you this. That's why, though my writings are not proper here, I'll be doing this and showing you, which will be more clear. So I'm going to repeat it again. See, we got two switch. And let's say this side is auto. And I want to do trunk configuration on fast Ethernet 0/1 on switch A. Say I'm on switch A. Global configuration mode. I say interface fast Ethernet 0/1. I will be inside the interface. If this switch has got both the ISL and .1 queue, then you say what? Switchboard trunk encapsulation .1 queue or ISL, whichever you want, and then followed by switchboard mode trunk. So this is on mode. Now assume I got VLAN 10, VLAN 20, VLAN 30, VLAN 40, VLAN 50. Down here I got only VLAN 10, VLAN 30. Only 10 and 30 members are connected here. So it is unnecessary to send VLAN 20, 40 and 50. Not necessary at all. So if that is the case, what I can do is I can go to the same interface and say switchboard trunk allowed VLANs. This is the command. When you put question mark, you will see a lot of options. Allowed VLANs none means no VLANs will be allowed. Allowed VLAN excluding, there will be a command excluding 20. So excluding 20 means it will allow all the rest of the VLANs. Allow VLAN 20, 30 or allow VLAN 10 and 30. So there are various options available for you. You can use any one, whichever you like, which will meet your need. For me, I want to allow 10 and 20, so I'll say 10, 20. That's it. Now, VLAN 10 traffic can pass through. VLAN sorry, 20 I don't want to allow, right? 30, this is 30. So I'll say 30 here. Now VLAN 10 can pass through, VLAN 30 can pass through, VLAN 20 will come and say, no, 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 not allowed, will not pass through. So this is for traffic filtering in layer 2 by allowing and denying VLANs by using trunk. This is the command that is practically in use in real world. There is another concept called VTP pruning, which I am going to teach you after VTP topic, that is not at all used anywhere in real world. VTP pruning also does slightly same like this job, but not this efficient, not this good. Somewhat same like this, but not really superb like this. Straight away you can say I allow only 10 and 30. Done. But pruning is like automatically it will see pruning. If I enable here, it will see whether there is really 20 and 40 and 50 members are there in the down switch. Because there is no one, it will prune it. It will send it. Because there is no one to receive it, it will prune it. But that's not at all a good protocol. VTP pruning is not a good method. The reason is you need to have all Cisco switches. Plus, it needs to be VTP server switches. It cannot be a. We are going to learn VTP. In VTP, there are 3 different kinds of mode: server mode, client mode, transparent mode. So if you want to enable VTP pruning, you need to be always in server mode. But in real world, that is not possible. Only 1 or 2 switches will be in server mode, all the rest will be in client and some will be in transparent. Pruning cannot be done on every switch. So that is again another drawback. One drawback is you need to have all switches as Cisco switch, which is not possible. Plus, it's a Cisco proprietary. A lot of company policies will say no proprietary. Do not use any proprietary protocols. So company policy will be like that in many companies. So VTP pruning cannot be used. Which is best one to filter VLAN traffics? This is the command. Switch port trunk, allow VLAN, so and so. Allow VLAN except this. Allow VLAN none. Allow VLAN all. You no need to say allow VLAN all. By default, all VLANs will be allowed. But there is also an option called allow VLAN all. There is also one more command, allow VLAN include. See, today I allowed 10 and 20. I want to include 40. Use include command 40. So that 40 will be added to this. Tomorrow I want to remove VLAN 10 from the allowed list. Exclude. Switch port trunk allow VLAN exclude 30. So there are various options you can see when you put question mark. Even packet reset supports all that I said. This is about trunk VTP. VTP has got 3 different mode. One server, the other one client, the third one is transparent. First thing we need to understand what VTP is. VTP stands for VLAN Trunking Protocol. VLAN Trunking Protocol. VLAN Trunking Protocol. Now, is there any connection between trunk negotiation and this protocol? No. Trunk negotiation protocol is DTP. Dynamic Trunk Negotiation Protocol. .1Q and ISL. But this T, though it says trunk, it has no connection between negotiation of trunk, but it has got connection with trunk. Meaning, It is not going to negotiate any trunk, but it works if you have the interface as trunk. If your link is trunk link, only then VTP can run. Meaning, if I have two switches, I got two switches, and between these two switch, I have a link, and that link is an access. And if you want to have VTP to work, it won't work. If you have an access port here, access link, it will not work. VTP will never work VTP will never work on this link. What is the condition? You need to have a trunk link. If you have a trunk link, then this protocol will replicate VLANs. That's the magic. This protocol will replicate VLANs over the trunk. What does replication means? I create VLAN 10, VLAN 20. When I go here and see show VLAN brief, I see already VLAN 10, VLAN 20 created. But who created it? No one. Then how it is there? How it has come? Through the replication of VTP protocol. I delete VLAN 10 from here. Automatically from here getting deleted. I again add VLAN 10 here. Again it is getting added. Who does this? VTP does this. Now I want to make something more to it. I want to add something more to it. Let us come again. See, we got a trunk, and this protocol can replicate VLANs if I have a trunk link. I got a trunk link, and I create VLAN 10 and 20. The moment I create VLAN 10 and 20, there will be a packet called VTP update going with this update. What is that update? VLAN 10, VLAN 20, revision number 1. Revision number 1 means this is the first packet, first update going. Now this switch is receiving. This switch is receiving that update and seeing the revision number first. What is the revision number that is coming in? 1. And what is my revision number? 0. Initially, all switch will have revision number 0. So it says, my revision number is smaller than the incoming. So I am not updated. So what I'll do is, I'll update. So it will take this 10 and 20 and write it to the VLAN.dat file. VLAN.dat file, which is there in flash memory. VLAN.dat. VLANs are saved in a flash called VLAN.dat in flash memory. In flash memory it is there. So to this file the VLANs are written. Now what happens is, when someone deletes the VLAN, it again sends the update. Update, new update, VLAN 20 only. What is the revision number? 2. What is the previous revision number? Previous revision number on the right hand side switch is 1, because it got updated. 1. Now because someone deleted a VLAN, immediately the revision number will get incremented, and the new update with the existing VLAN goes. Receiving switch, what it will do, it will compare the incoming revision number with the local revision number. Because there's a difference, incoming is bigger than the local, what it does is, it completely removes everything in the database first. It completely removes everything because the revision number is different. Because the incoming is higher, it will first remove everything from the database, and then increment the revision number from 1 to 2, increments and takes this VLAN information. This is how VTP update happens. Now I add another VLAN. I put back VLAN 10. What will happen? Again there is a change. Whether you delete or add, the revision number will increment. So now the revision number gets incremented to 3. So now VLAN 10, VLAN 20, revision number 3. Now this update approaches the right hand side switch. It compares the local revision number with its own revision number, incoming revision number with its own revision number. Incoming is bigger, so what it does? First job, remove the local database information. And then second job, increment the revision number. Third job, add the VLAN that is coming as the update. So this is how VTP update happens. The purpose of VTP is to replicate VLAN. It can work only when you have trunk link. Now let's talk about the 3 different modes we have in VTP. VTP has got server mode, client mode, transparent mode. Now, when we have some switches, and all the interface between these switches are trunk interface, trunk interface, trunk interface. Trunk interface between the switches, and let me name these switches as 1, 2, 3. Right, we got 5 switches, and the links between these 5 switches are trunk links, no doubt. Now, by default, when I say switch, when I go and check VLAN, so when I go and check VTP by typing this command show VTP status, I can see that VTP by default in a server mode. That's a default mode in any switch. Default mode is server. And I also can notice that there is a field called domain name, and that is blank. What is domain name? Now the next prerequisite for VTP to run, first prerequisite is the link should be trunk. The second prerequisite for VTP to work is all the switch should be in same VTP domain. Don't worry too much about domain. Domain is nothing but group. Means all should be in same group. Only then the VLAN replication will happen. By default they don't have any group name. So we need to give a group name. For that you need to go to the global configuration mode and say VTP domain, any name. You can say VTP domain name my LAN VTP 1, my LAN VTP1. This is a name. Can be any name without a space. So I put underscore. Done. Now this has to be the same name, same capital letter or small letter, same case sensitive, same case, upper or lower case, has to be given or configured on every switch. In the global configuration mode, I give the same command, same letters, everything same. Now when we give like that, they all form a group. They all are in same domain. Now if this is there, they are ready to be used. VTP is ready to use. First thing, the link should be trunk. Second, they all need to be a member of same domain. Now they're all same domain and trunk is there. If I create a VLAN here called VLAN 777, I can see that VLAN 777 every switches, in every switches. What is the command to see the VLANs? Show VLAN brief. To see the VLAN, show VLAN brief. It will show the VLANs. You create in one switch, it will be there in every switch. Can I create in switch 3? Will it be seen in switch 1? Yes. Any switch you can go and create. The reason why you can create in every switch is, by default, all switches are in server mode. In server mode, you can create, you can delete, you can modify, means you can go and change the name of the VLAN. You can modify VLANs, which is not possible in client. In client, you cannot create, delete or modify VLAN. But in transparent, you can create. You can create or delete or modify VLANs in transparent. So what do you see here? The difference. Difference is only in the client. On the client, I cannot create or delete or modify VLAN, but on transparent and server, I can create, delete and modify VLAN. Now, fine. I understood the difference between server and client, transparent and client. Now, what is the difference between server and transparent? If you can create or delete or modify VLAN on both, what's the difference? One difference you already know, server is a default mode. The other difference is, when you create or delete or modify VLAN, VTP updates will get generated and sent to the other switches. Means, when I create VLAN 777, immediately the update will be generated and sent to all the other switches with a higher revision number. Whereas in transparent switch, VTP updates will not will not generated, will not generated and sent. Reason why. In transparent switch, revision number will be always 0. Always. I create a VLAN, revision number is 0. I delete a VLAN, revision number is 0. If revision number is not allowed to increment, then VTP cannot be generated. Only when there is a change in revision number, VTP will be generated. Whereas in server, whenever the change happens, you change a name for the VLAN modification. Revision number generates, increments, and VTP generates. You delete a VLAN, revision number increments. So VTP update will be generated and sent. So transparent switches, because their revision number is always 0, whatever the change that may happen to the VLAN database, they are local, not going to be sent to any other switch. Not only that, this transparent switch will not accept any VTP update. You know why? Update. Same reason. Not allowed to increment revision number 0. They're not allowed. They're not ready to take new revisions. So if new update comes, that doesn't make any sense to transparent switch. So they don't take any update. They remain dumb for all the updates that is coming. But if I have a transparent switch here in the middle, and this may be client switch, this may be another client or server, this may be another client or a server, and here I have a server. When I delete this VLAN 777, the updates from the server will go to the client will update it, client also will remove 777 and send the update to transparent. Transparent will take the update, but no synchronization. Client takes the update, synchronizes it and sends it. Means synchronize means what? Changing according to the update. Transparent will get it and just forward it to server, the next guy, without any change to the local database. Server takes it, changes the local database and then sends to the next guy. He receives it, changes the local database, which is called synchronization to the update, sends out if there is any more. Whereas transparent mode will not accept any VTP update. To be more correct, it will accept and just forward to the downstream switch, without synchronization. Without synchronization. Now, so it will accept. Whereas this client will accept VTP update, synchronize its local database and pass the VTP update to the downstream switch. Client cannot generate any VTP because you cannot first of all create or delete or modify VLAN. You cannot do any changes to the revision number. Changes to revision number in client can be only done based on the incoming update. You cannot create or delete VLANs. Now you can also see that server switches, they receive from a transparent, synchronizes and send it to another. So server switches can also pass the information received from other switch. So these are the difference between server, client and transparent. So transparent switch will not get affected to the VLAN creation or deletion or modification that is done on the other switches. Though the transparent switch is connected to this domain, to this layer 2 domain, it is independent to what? To only VTP updates. Independent to only VTP updates, very important. What do I mean by that? I have a computer here in VLAN 70. I have a VLAN I created in transparent mode, transparent switch separately, VLAN 70. This also in VLAN 70. Can this be ping A? Yes. Only VTP, this will not get influenced. So transparent switch is not getting affected by any VLAN. Now if I remove VLAN 70 from here, still the VLAN 70 will be here in transparent. Will not get removed because it is independent. If I have same VLAN on a transparent switch and a client switch, I can ping this PC to that PC. So only VTP level they are independent. Transparent switches are independent. Now on the security side, we have something to think about this VTP. What is that? When you have a switch, it may be a client switch or a server switch. It may be a client or a server. Let's say it has got a revision number of 50. And this switch is configured as client or server. Anything, that doesn't matter, client or server. I have a switch which is a server in my office. I have a lot of switches. And these are all, assume, these are all server or client, whatever. Now, this has revision number 50, but no VLANs. I deleted all VLANs. Even if you delete, the revision number will increment, you know that. And your office is running with two VLANs. Let's say VLAN 10, VLAN 20. Your office is running in VLAN 10 and VLAN 20, two different networks, two different layer 2 domain, virtual local area network. It's running smooth. Now I want to add some PCs to this existing network, but there is no port available in any switch. So what I did is, I take this switch, which is my old switch, with the same domain name in it. Let's say the domain name is 123, 123, 123, 123, 123, 123, same domain name. I just take a wire and connect to this server switch. You know why I'm doing that? I want more ports. I want to connect some PCs down here. And what is the revision number? Here it is 50. And what is the revision number here? Let's say the revision number here is 11, 11, 11. Which is bigger? 50 is bigger. Always the higher revision number overrides. Even though it may be a client, the moment it is sent, the moment it is connected to the server will send, hey, my revision number is 11, take my VTP update, VLAN 10, VLAN 20. When this goes to this switch will say, wait a minute, I got revision number 50, you got just 11. Take my update. What is there? Nothing. What is my revision number? 50. The moment it receives the higher revision number packet, it will first delete all that was there in the database and then do what? Copy what is coming. Copying nothing. So your VLAN will be empty now. What I am coming to say is, a revision number matters. So when you add a switch to the existing network, make sure that switch's revision number goes to 0 before adding it. If you send with a higher revision number, your network will break. Why? All the VLANs are removed now. Your network was smooth because of the VLAN. Now the entire network goes down. To avoid that, make the revision number 0. How to make revision number 0? Very simple. Change the domain name and put back the same domain name if you want. 123 was my domain name. I had 50. I say no VTP domain 123. I delete. The moment I change the domain, it will be coming to 0. And put back the same number if you want, same domain name if you want, it will be 0. That's the easiest way. Another way, change into transparent mode and then put back server or client mode. When you change to transparent mode, what happens? The revision number goes to 0. You know that. And put back the mode you want. Then it is 0. By deleting VLANs, you cannot bring the revision number 0. It will keep increment only. Any change done to the VTP, whether it is creation or deletion, it will increment only. So the best way to make the revision number 0 is change the domain name or change the mode from client or the server to transparent and put back if you want client or server. There is also one more way. Delete the VLAN.dat file from the flash. Go to the switch and say delete. Delete flash VLAN.dat. It will ask for confirmation, confirm, and then reload without fail. When you reload, you will see all VLANs are removed and it will be in revision number 0. So these are the options in making the revision number to 0. This is the precaution that we need to take before adding any switch to the existing network. VTP is dangerous. That's why most of the people, they don't use VTP. Mostly nowadays people don't use VTP. But it is there, we need to learn because it's there for exam. It is there being asked in interviews. That's why we learn this. So that's all about VTP and DTP. Yeah, any doubt? There is a drawback in this router on a stick. What is the drawback? What if this link fails? You lost inter-VLAN routing. There is no routing between these VLANs. What if what if what if this router itself fails? Again you lost inter-VLAN routing. Or think about the bandwidth. This motherboards work in 10 Gbps speed. Very fast. So the packet comes from here and processed and sent via just 100 Mbps or 10 Mbps wire. Bottleneck. And again processed and again coming with a very speed of backbone, the back panel, 100 Gbps speed, motherboard speed, and comes down via a narrow path, 10 Mbps or 100 Mbps. Again processed and sent to the other VLAN. So what we see here is it's not really a good design. And then multiple time this is getting processed. They're getting processed again and again multiple times. First you need to get processed by this and then this and then this and come again here and come again here and then go here. Not bad. It's a not good. Bad. So what is a good approach? Take this box, keep it over this, finish. Single box solution. Now if you have routing capability along with switching capability in a single box, packet comes processed in single motherboard, finds the exit, goes here. It is both switch as well as a router. Less time consuming. It is very rare Cisco switch will go down. This link can go down, but you don't have a link now because you got a multi-layer switch, a layer 3 switch. A layer 3 switch which has got routing as well as switching capability. By default all the ports are layer 2. If you want layer 3 on the interface level, you can enable, or you can create virtual interfaces called SVI, switched virtual interface. For this VLAN 10, I can have one SVI and I can give this gateway address there, 10.0.0.3 in this layer 3 switch. I can create one more SVI. This is for VLAN 10 I created. Now I'm creating SVI for switched virtual interface. It's a virtual interface for VLAN 20 members. I give the gateway 20.0.0.3. Now I can see in the routing table both 10 and 20. So routing job also happens. Switching, these interfaces are layer 2 switches, layer 2 interfaces. Switching also works. So this is a good solution instead of going for a separate router connected via low bandwidth cable like router on a stick. So this is the good option. You can trust on, go with. See, people used to initially say, oh, these multi-layer switches, they're very costly, Um, they are very, very costly. It's not that cheap. No, I tell you, nowadays switches have come very, very costly. So this is no way costly. These multi-layer switches are nothing when you compare to Nexus switches. Very costly setups nowadays we have in the network. So this multi-layer switches, the only drawback they talk about multi-layer switch when they compare to router is this is costly. All other things are advantage. Only drawback is they say is costly than a normal layer 2 switch. Yes, it is costly because it has got both routing as well as switching capability in it. It's reasonable. Single box and maintenance also less. Only one power connection unit, so power consumption also less. One box only you need to maintain. Before you were maintaining two box, one router, another one switch. Now you maintain only one box. So less space, less cooling effect. If you have more devices, more cooling needed in your room. The rack mounted, the rack room. Now you need less cooling. Good. So these are the advantage of having a layer 3 switch. So in the next class we will continue talking about the layer 3 switch, the configuration part, and we'll also discuss about something called CEF, Cisco Express Forwarding. After that we will get into layer 3 redundancy, which is HSRP, VRRP and GLBP. This is for our tomorrow's plan. Tomorrow we are going to discuss about layer 3 switching. We are going to continue with this multi-layer switch, which is layer 3 switching. And then we'll discuss about CEF, and then we'll talk about layer 3 redundancy protocol like HSRP, VRRP and GLBP. So is there any question you want to ask? You can ask now. Should I take it as no? All right.